This is Shrikant Rangdal, and some days back, my YouTube channel crossed 5,000 subscribers, and I would like to thank everyone who has supported me through all these times. And I hope that you will continue to support me the same way that you have been. So, in today's video, I'm going ahead and we'll be doing projection of sections of solids in today's video. So first let us take up a cube and see what all are the different cross sections possible with this. So first over here we have a cube with its vertical edges equally inclined to VP, and it's resting with its base on HP. And if the on the cutting section, if it is cutting it like this, crossing these two edges over here, what is the kind of true shape we will get for the section? And it's going to be not this. I can also show you 3D view of this, which I had created some time back. And right, so you can see that this is going to be a triangular cross section. Now, if the vertical faces are equally inclined to VP, then the section we get here is an isosceles triangle. So no matter how this angle is created, we will always end up with equilateral, isosceles triangle. So and if it is crossing two more edges, so that means this top point, if it is crossing over here and coming over this point, then we will get a kind of pentagon. This is not exactly a pentagon, so this is actually supposed to be a rhombus when it completes, and that is cut off wherever the section is crossing the top point. So here we have this cube, and if you see the top view, you can see that the vertical edges, both these vertical edges, they are equally inclined to VP. They are equally inclined to VP. And in this position, if we take up the front view, and if we take the section at this particular point, go ahead and take the section. Alright, so now the section starts. So you can see that no matter at what point this section, I can do from this point all the way till it doesn't cross in this particular place. Okay. So for all these positions, the true shape is always going to be an isosceles triangle. True shape is going to be an isosceles triangle all the time. So that's what we have drawn over here. Then as soon as it crosses these edges, our front view, see what happens when it crosses that line, or it crosses this line, and the section plane comes over here like this. And we can see that this transforms into this. So if these two edges are extended, we will get an exact rhombus, but this is cut off by the place where the section plane is cutting the top face. And this is what the section is going to be. And if it is crossing over like this, where it is cutting the bottom edge over here as well, let's see what happens at that point. If it hit it further, push it down back a little more, and these are the three edges that it is crossing. Now, what will the section look like? You can see here that the section looks okay. This section looks like a hexagon. Now the question rises: is this hexagon, is it possible for this hexagon to be a regular hexagon at any point of time? So for that, if you want to understand that, you'll have to this over here to the midpoint and adjust the angle at a particular place. And at a particular angle, you can see that this indeed looks, it is possible for this to be an exact hexagon, even though at this point it doesn't look exactly. This is slightly shorter. So it is possible for us to adjust the angle and make it exactly a regular hexagon. So let me try to do that. I want this to be an exact hexagon, then we need that angle to be, call it over here. Angle. Increase the precision in order to get the exact angle of text and units and the dimensions yes, with zeros get so we're getting 54.7. So that's got to be the angle. So we have first get this from angle. This angle needs to be and this has to be passing through the midpoint. Now, if you see this, it's an exact hexagon. It is possible for us to get an exact hexagon like this. The thing is, it's got to be passing through the midpoint of this edge, and it's going to be passing through the midpoint of this edge. So when we do that, it will also pass through the midpoint of this particular point, and the end result is going to be an exact regular hexagon, which means just to you right now. Dimensions, which is as this. You can see all the edges are same length, and also angle between any two edges is 120 degrees. So that's what happens now when it touches these all three edges. The midpoints, when it touches, we actually get a regular hexagon, and if it is not touching regular hexagon, if it is crossing at any other point, we'll get something like a particular kind of a so just show you that as well. It is slightly different. You'll see that one set of edges are extremely long compared to other edges, and this will continue to happen depending on where we take. Depending on where it touches. Let's go ahead and see another possible scenario wherein this is when it is crossing these two edges. Then what is the cross section? Will end up here. This angle. Like this. This is how the cross section. This is what the cutting plane used to be here. Let us see what kind of cross section we will end up getting in this position. So we can see here that these two edges are parallel, and these two are kind of like this. So we are getting trapezium, which is symmetric about this particular axis. So we end up getting a trapezium. You can see the curve shape over here. Okay, so that's. Go ahead and see what happens if it is cutting it totally. Both the side edges, if it is cutting. If it is cutting both the side edges, then the top is going to be like this, and the curve shape that we get here will be around this. This will be what I described over here. If these two lines are left to extend, and at some point, if this edge is extended, if the height is increased, and if this edge is intersecting the cutting plane, then these two edges will expand, and we will get a this. That's what is happening over here, because these both the side lines are being crossed. And this one is much more simple. If the section plane is horizontal, exactly, we'll end up getting a full section in the top view itself, and that's going to be a square. If the cutting section is cutting here, the top instead of the front view, then these two lines will go up, and we will again get the true shape in the front view itself. And this shape, you can see it's a rectangle. Is it possible for us to get a square over here? Yeah, it is possible. We just need to keep moving it upwards at a point wherein this length becomes equal to the edge. That's the point where we will get a square over here. Alright, so I guess we've got things. Okay, so here there are some additional possibilities. Let's try to cover them as well. In this position, you can see that the cube is placed in such a way that vertical faces are either horizontal or parallel to VP, and it's resting first with its base on HP. And when the section plane is cutting over here like this, what's going to happen? Let's take copies of all these possibilities down here. Let's try to project the true shapes. First up is this one. So we're going to use the break command to remove the points, and now this is actually going to be a section, so we're going to make it dark. These will cut off and remove, so let's just keep them as construction. At this point, it co-interfered with this offset through this part. And this line will become our this line will become our x1 point, x1 here. This line need not be dark, so it just needs to be light, just like this. Okay. So actually x1y1 line needs to be vertical to generate the side view, but in this case we have not generated the side view, so we can just go ahead and take. Then we need to project the true shape of this over here. In order to generate the true shape, we will need a line which is perpendicular to this. So in order to get that, we will just use the same method that we had used to copy and create a normal using a tangential line. So let's go ahead and take the rotate command. Select this, enter. Then I'm going to click one of the endpoints and rotate it by 90 degrees. But before clicking for rotation, I'm going to just select the copy option up here. Click copy and click here. This line will also remain, and this line will be created as a copy in the rotated position. Now this is a line we just need to move it. And then offset through needs to be used wherever we have an edge crossing. So top view, what happens to the top view? The top face is being cut over here. So we'll get edge. This is going to remain in section. Go ahead and enter this, choose this option, and now for creating the true shape, let it closer so that less space is required here. Now whatever is distance from this to this and this to this, so the same distance we have to take from over here. Let's create circles of these and move it over here. These are the points we need. This is point intersection. This side as well, the distance is same, so might as well use the same circles here. Once again, we need to extend this. Needed. Keep a point here. This gives us the true shape. We can see the shape here is rectangular. It is rectangular. Unless this length over here is exactly equal to the length of one of the edges, this is going to be a rectangle. Okay, with that, we just need to do this. Now let's see the next over here. Here you can see the section plane was cutting the top face over here. Here, on the other hand, it is touching this face over here. Let's go ahead and do that. Break command needs to be used for this. This construction line, dark, and now going to enter, take it to this. This line we will use it as x1 y1 line. Let's scale it. Increase its length. Properties of this. Let it keep the text. So if you've already used x1 y1 for creating the profile view or the side view, then you need to use x2 y2 here instead of x1 y1. Okay, so let's go. Now the sectional top view is going to be entirely in section because it is cutting both the edges. Straight away, this is going to be the top view, sectional top view. In move this using stretch command to do this. After this, we have to again create a perpendicular line to this. Use rotate command, and before rotating, let's get a copy. This we need to move it. So it creator we need to use it and parallel to this from this point. Now we need to take the same distances, and you can see the same distances are present over here as well. So on both these points, from x1 by 1 line, we need to mark points. Same points mark over here. So once the work is over, you can remove it. Again, PL enter can be used to join all these points. Match properties can be used like this. Match command. This is the true shape of the section if the section plane is crossing both these edges. Let's see what will happen. The section plane is cutting the top face as well as the bottom face. So again, let's start with the break command. This, this right side part will be removed completely. This here we will get the section. Let it create one directly enter. Let's scale this, double the size, make it simple. This becomes our x1 by 1 line. Then we need to rotate it, getting a copy. Let's move this. Pointer enter used to create parallel lines to this. And yeah, the sectional top view. For the sectional top view, we take from here. Right, the same hatched part. This is not the true shape because the section plane is inclined. This is not the true shape. You need to get the true shape over here. So for doing that, oops, the section plane is over here. this point, intersection between the circle and these points. So take this same. Okay, PL enter can be used. This is the true section. Dark. Boundary needs to be dark. Inner hatch. Inner. Okay, so this is the true shape. This is the section top view, and this is the front view with the section plane. Let's see. So in this case, instead of in the front view, the section plane is visible in the top view, and this means the front view is going to be in section. Let's go ahead and start doing the same thing. Click command, goes here. Mesh properties. Go enter, T enter, scale it, double the size, match its properties with this. So the name of this one. Again, we need to create a perpendicular line to this. Use rotate command, rotate about this point, and before rotating, let's create a copy of this in the option. Move this over here. Now, for the sectional front view, to take it from here, this, like this. Now here you can see the section plane is touching the XY line directly. The first point is going to be at the intersection itself. First point is going to be at the intersection of one by one and the perpendicular lines. About the second point, we need to take, and this distance remains the same from both the points. Take this from here. Okay, polyline command, PL enter, join all these points. This is going to be the true section. I'm going to hatch it. Okay. So this is the true section. You can see this is a rectangle. We're getting a rectangle here, getting a rectangle here, we're getting a rectangle here and here. So no matter how we are cutting the section, we'll always end up getting a rectangle. There are also possibilities where we can get squares, exact squares in this position. One possible position of that is if the second plane is horizontal in either front view or top view, we'll end up with exactly a square. And if the section plane is vertical in top view, side view, we'll also end up with a square cross section. Except for that, any other lines, I think will always give us a rectangle. Not all positions. I think if this length over here is equal to this length over here, at that point as well, we will end up getting a square. These are the different possibilities for sections. So in the model, I'll be posting this as a question. As a question will be posted in, and students would have to develop these diagrams at the bottom. Of course, they'll have to find out the areas and perimeters of the true sections and sectional top view or front view, whatever it is. They'll have to feed it. They'll have to feed it into the model answers. So after having done with the cube, let's go ahead and see triangular prism. Again, you can see the question diagrams have been given here with the section plane given here, front view and top view are given. One of the base edges is parallel to VB. This is the position in which it's resting. And for all these other positions, we'll have to find out the sectional top view and the tube shape of the section. Let's go ahead and start doing this. The list is very big. Let's copy this. And let's start. So over here, we'll have to start of course with the break command. BR. Let's click somewhere above this line, and then on this line we will get the intersection point. Then again break command, click on the right side of this edge and then click on this point exactly. Mesh properties, these all lines, construction lines. This becomes a solid edge. When it comes to the top view, the entire face will become the section. Okay, and this itself is the true shape of the section because we can see that the section plane is parallel to the xy line. That's why we will get shape here. The side view is going to be almost the same still, so we'll skip the side view. Let's come over here and see what happens when the section plane is cutting these two edges in the front view. The first thing we'll have to see is because it is touching it's cutting the top face. The point of intersection of this, we will have to draw a line here. Okay, this edge will become a visible edge. Let's be made dark. This will appear in section. Let's do hatch. Now for the true shape of this, we'll have to break this again. Section plane also needs to be this becomes this part is removed. And for the true section, point of T enter we have to use this. Let's scale this at the midpoint, make it double the size, make it light with this. This becomes x1 by 1. Let's go ahead and take it as x2 by 2 because I want to draw the side view of this as well, sectional side view as well. That's the reason I'm taking it as x2 by 2. X1 by 1 we will take it on this. This line we will take it as 1. We'll need some space for this extra. Okay, so the side view we're going to draw over here. Then the true shape we're going to draw. Let's first create a complete side view. We'll create a complete side view. You have to draw horizontal lines. You take this point. Take this. Okay, so this is the view. Now we need to take the true shape. So for true shape, we have to duplicate command. We need to copy this and to this. Move it here. Take outside the code. So now we have to take this length, then two lengths. Let's take a polyline. So we can see here that this one is a right angled, the same section. If you want to show it over here, you need to do, okay. Let me take a line from here. Enter. This is the point where it is touching the top face lines. So here we got one point, then this edge is being cut. Edge is over here. This is one point. This is the second point, and the third point. This is cutting the back side. Third point is going to be this edge is over here, not the right point will be over here. Because this is the point we want. This is the point. This point is on this edge. This edge and this edge. It's going to be here. Going to this point, that's going to be at the top. So let's take a polygon again. This is the sectional side view. This is the full shape of the section. This is the sectional top view. That completes that. We use the stretch command to reduce the size of these. And that's thing. Let's go ahead to the next position. Here you can see that the section plane is cutting both these edges. So what will the sectional top view, sectional side view need? First of all, let's create this side view this so that let's create these lines. Circle we need to create here next. And these lines are this pointer pointer. Okay. Now we are ready to create the side view. Here, here, here. Okay. Now it's time to do the section. So as soon as we do the section, this right side part is going to be on. Make this. Right side is going to be gone. So let's that. No plane, let's make it. Because this becomes visible Then this cut this entire face, top face also will be cut this edge. Hatch command. Okay, so this is the sectional top. This part is going to be removed entirely because it is cutting through the bottom face as well. But here, in the previous case, the right side part was not gone entirely because it was the section plane was not cutting the bottom face. Here it is cutting the bottom face, so the right side part is going to be entirely gone. This is going to be the sectional face. In top view, we need to draw what it will appear like in this view. The top and bottom faces both are cut. This is these points are going to be and bottom. So here, let's go ahead and name these points so that it becomes easier for us to one, two, three, and these points in the table. 1 and 2 will appear dash and 3 dash 4 dash. We need to get the same points over here in the side view. Now 2 dash and 2 dash. Enter 2 dashes here. This point here is the side view. That's viewable. Okay. And then 3 is going to go to come here. This point is and 4 and 1 both will be matching with this. 4 is going to be at the bottom here, and 1 is going to be at the top. This is 1 double dash. This point. Points. This is our sectional hatchet. So sectional top view, sectional side view, and the front view with the section plane. This is how it's going to be. Now, in the last step, we'll have to draw the boom shape of the section as well. Enter through point here or beyond that. We'll have to scale this, make it double the size, match property this. This line is going to be x2 y2. This x1 y1 we have already used here. X2 y2. Then this that we can create this tube shape over here. And next we have to create a copy of this perpendicular. Rotate it. Take a copy of this perpendicular. Move this here. Put a T into Okay, circle. There's an error. Be careful while creating it. This has to come over here. 4 points over. Let's take here. These are good points. So running these points will give us the true shape. You want to name the point, you can name that as well. So this point here, this is the nearer point, that is 1. This is 1, 2. This one, 5.3. This one, nearer one, that is. This is the true shape of the section. This is the sectional side view. This over here is the sectional top view. Now, yeah, take a look at it. You can pause the video if you want to take a look at it for more time. And let's go for next diagram is over here. You can see the section plane is cutting here across, cutting the top face over here and the side edge over here. Go ahead and see this. First, of course, let's create side view. In this one by one. Yes. Okay. Now this side view is going to be same for all the diagrams. Let's copy them in all the diagrams. And here. Same thing, we need to copy all these. Okay, so the side view is, so let's go ahead and create this. First, let's create the sectional top view and side views. So for that, first do and double its size about the midpoint. Okay, we'll do this later. Okay, keep it aside for some time. First, let us take the sectional top view. The sectional top view is going to be here. Okay, then let's do the numbering over here. Numbering this order 1, 2, 3, and 4. Just drag it out a little. Okay. The same points we need to take them here in the front view before we go for the side view. 1 and 2 with both will both overlap over here. So they're going to be 2 dash. Then this point this point. Sectional top is over, front view with section plane is over. We need to create the side view, sectional side. With that, we have to take the points. So 1 and 4 are going to be on this line itself. 1 is going to be at the top. 4 is going to be straight from here. This is going to be 4. So this is 1, 4. Next, you need to take 2 and 3. So 3 is over here. Take 3, and the line from 3 is going straight. This you need to take the section of this. This is point 3. And lastly, about the point coming over here and it's cutting the top face. You need to take a straight line through, take it all the way up to this point. This is take line to join them. 1, 2, 3, 4. This is our sectional face. Let's do the hatching. Okay, this is the sectional plane. We will just see if any of the corners is missing totally. This corner is gone. This right side of that is gone. This part, the top view is gone. That means for this, the top view is gone. That means this corner also will be cut away. Okay, this is the sectional side view. This is the sectional top view, and now we need to proceed to draw this tube shape. Like this. Move this point. Take outside 2. Okay, now number one we need to take. For the point number 4, it is at this distance. So from x to y2, you have to take the same distance. If you were to name this line, this is 2 over. Next, you have to take this distance. This point is 4. This point is 1.3. We have 2 points here. This is the nearer point. 1. This is the far away point. This 23.4 gives us true shape of the section. Match the properties to make them borders. So this is the true shape. This is the sectional side view. This is the sectional top view. Let's see what happens over here in this case. Now here you can see it's cutting both the top and bottom faces. So let's start. Side view is already created, so we don't have to go ahead and do that. Let's start with the big command straight away. Wherever the section plane is touching the visible edges, we need to break that. The left side will remain, the right side is going to move, and this break it at the bottom as well, and this will become a visible edge over here. Now we need to take this here, cutting. This is where it touches the top face. This, like this as well, here and here. So the right side, will be gone. This becomes, these two edges become visible edges, and the edge will appear here on both the sides. Okay, so now let's give the numbering. So let's start here and here. This is 1, 2, 3. Okay, the same numbers would also 1 and 2. Yep, so 2 dash here, dash here, 4 dash. So 1 and 5. So the 1 will be the top, 5 will be the bottom. So 1 dash. Then 2 and 4 we have to take lines. 3 will be here. 3 is cutting this point. So from here, take a line, this point. Let's go ahead and do 0.2 is at the top, and then the point that point is at the bottom. So one more point right here, that is coming from 1, 2, 3, 4, 5. Let's join up these points. 2, 3, this. Let's do hatching. Lines. And this corner of here, the top corner, this, see, that has been removed. So at this point, these lines will also let's just make it as a construction. So this is the sectional side. This is the front view of the section. This is the sectional. Going over to the true shape of the section, and you have to take double the shape of this. This line is and we need to take properties, right? Rotate this, copy, move this here, offset it here, those important points. Take circle command, here. These two are coming from the top. See the names. So this is the near point 5, away point 4, point here we have near point 1. In the same order. In hatchet, okay. So this here is the true shape. Okay, you can pause the video to check it out in detail and do it accordingly. Next, let's go for next one is over here. this will be much simpler. Bit of the side is already done. Let's go ahead and take this away. Go away. Entire top view is going to be in section. Names, 3 points. 1, 2, 3 points. Here, 1 dash, 2 dash, and above 3 we will get 3 dash. Same we have to here. This is coming over here, so here this point is going to be then 3. Two beyond this edge. This is like this. Because the top side is entirely removed. Dark. This face section. So this is the front view with section. This is the top view, sectional top view, and sectional side view. Once again, we have to go ahead and create the true shape. This is white line. Create a rotated copy of this. Move this. Now we need to take the distances. This distance here. This distance is up to 2. So for that, let it hold the enter 2 and this distance this. So this is the true section. Finally, we are done with all these views. Side view is not about this. whatever side views required, you have drawn them, and you can pause the video and take a look at all these solutions yourself. And next, for this, the side views can be slightly different. This. This will have to be applied from here. Inside this. Okay. This one is not needed. This go ahead. This will be this. This. Will be the sectional view. Here, let's 1 point.